Welcome to our first Raspberry Pi meetup group. It's not going to be like this going forward. It's going to be more hands-on, working on projects. But a lot of people kind of had questions and all that. We threw this one out as like an introductory type thing. Plus I had this talk in the bag, so I've given it at a couple conferences now. And it made it easy to have content right at the beginning. You don't need to write anything down from this talk. It's all at speakerdeck.com/VINULL. So some of the slides that I have a bunch of commands on them and all that, and I go by too quick. Don't worry about writing it down. Just hang out and watch the presentation. All right. Maybe. There we go. So first up, if you're not familiar, what is the Raspberry Pi? I had somebody earlier say they thought it was related to BlackBerry. Like it was some kind of like Android for BlackBerry thing going on, which I guess I can see that. I guess I can kind of understand. But this is a Model B Raspberry Pi. And on the Model B, the specs they have here, you've got an RCA video out. You've got an audio, just your regular 3.5 millimeter audio jack stereo out, 2 USB ports, the networking LAN 100, but it is also, this is actually a USB adapted network port. So the network is running off the USB as well. So sometimes you'll see it say it has 3 USB ports in some documentation. That's why. One port's being used by the network. You've got an HDMI port, a power port, which is powered off of a USB connection. These little pins down here are what's known as GPIO, General Purpose Input Output. You can program them to be whatever you want them to be. This is how you hook it into other devices and robotics and extend it beyond. Or even little simple things, such as hooking up an IR sensor to create a remote control for a media center, right? I'll talk about a little bit later, some of the RetroPie and the console arcade thing, but it's well documented now how to take a Super Nintendo or a Nintendo controller and wire this up directly to the GPIO, so you're not going through a USB emulation layer, no lag on the input of the controller. So that's some little fun projects there. You also have some expansion ports here and here. Right now, the only thing officially using these is there's a camera module that can be used. And when you get your Pi, they have a little bit of yellow tape on them. If you don't have an expansion to plug into that, just leave that on there. Dust is never a good thing in electronics, so and they're really fine connections. It'll be a really fine ribbon cable when you get a connector like that. It's a 700 megahertz ARM processor. An ARM processor is the same thing that is in your iPhone, Android phones, very, very popular. Specifically, it's an ARM 11 gen processor. It's 700 megahertz. You can overclock it up to 1 gigahertz. In fact, that's even supported by the Raspberry Pi Foundation. They'll give you some software that you can use to overclock. Now, it may not run stable. No guarantee that every Pi will run fine at 1 gigahertz speed. But you can do that and not void a warranty on the device. The GPU runs at 250 megahertz and pushes the same number of triangles and pixels as the classic Xbox did. Okay, so while this board may be underpowered from a CPU perspective, the GPU is pretty powerful for what's inside this box. The B has 512 megabytes of shared RAM. You can still buy the Model A. The Model A has 256 megs of RAM. It has 1 USB port. It has no networking. Why would you ever do that? Because it has a lot lower power consumption, right? About 1/5 of the power consumption of the B. So if you're going to make a Raspberry Pi and you're going to stick it in a box with a camera module and do a time-lapse photography that runs all day long, you may want to get your hands on a Model A. A Model A is $25, the B is $35. So that's the basic of the hardware in this little bit. There's some additional video support that you can get with the Pi. I've mentioned this here already, that there's the camera module. I'm going to get one of these myself. Looks like you already have one. Awesome.
We can plug one in.
Yeah, later we'll have to play with that. So you can plug in the camera module. It's an RPF camera module that connects in here. There are documentation if you want to take a webcam and hook it up. You know, certain models of webcam have worked as well, so you don't have to have that model. But it's made to be a low-powered camera that can go with the low-powered Pi footprint for doing cool little projects like making a time-lapse photography box that you set out and leave out all day and come pick it up at the end of the day. On board, this thing can encode and decode H.264 video, which is pretty much the de facto standard. If you're watching video today, that's your Blu-ray, that's YouTube now, that's mobile video. Pretty much everything has moved to H.264 into the very efficient method and compact method of recording video. And the Pi includes a hardware encoder and decoder for free on the box. You get that. Encoding takes a little bit of hackertree work right now, okay? So if you're going to want to use this to encode video, and you want to use the hardware, you need to get to the forums and dig a little bit and figure out how to tweak that. The drivers shipping aren't unlocking that right now. It's just a matter of software and drivers and open source catching up to the capability of the board. But for decoding, all the drivers are already supporting the decode. You can also, for $4 and $2 respectively, unlock hardware decoding for MPEG-2 and VC1. Okay, now these are a little bit older, but not that old of video specs. VC1, its biggest claim to fame was Microsoft's HD DVD. So if you've got a bunch of HD DVDs you want to play through it, then spend the $2, unlock the hardware decoder. Also, if you're going to use your Pi as a media server, that's kind of the goal, then you can go to the Raspberry Pi store, put down $6, you'll get a key for your Pi that you put in a little text file on it that unlocks that Pi for hardware decoding of those video formats. That's all cool and well, and anybody that has probably come out to here today doesn't need this slide. Why not, right? I don't understand the question why. You look at this thing, it's cool, it's awesome, play with it, why not? But believe it or not, that's a valid question to stop and ask yourself, why make a $35 computer? Like, what is the advantage, especially how rough that is and all of that. And the answer kind of goes back in history. This is my first computer. It's a Tandy 1000 EX, 16 color and 3-voice sound. So this was screaming in 1985 when I had it. We had a debate in the family whether or not we should buy a second floppy disk drive or the 20 meg hard drive. And we voted for the second floppy disk drive because the floppy disk shuffle was quite annoying. And this was, time of the day. Excuse me. That was the way it was back in the day. Actually, this is not true. This is my first computer. This is hard to find. This is a Tommy Tudor, but if you type that in, you get this other toy thing. But there was this other one made that was a much more advanced model. It ran basically connected to your television set. It had cartridges that went in that you could play games with, and it had a cassette deck for saving your programs that I never got to work. Okay, I tried to write things to the cassette deck, and they wrote, and every time I tried to load them back, they failed. And when I failed to load it back, there was never enough memory on the machine to have the program in memory and load a second copy of another program in memory while you're reading it back. So it was a one-way deal. It was write the program, save it, try to load it back, it failed on load, and you've lost everything. But these computers are not pretty. They're not packaged. They're not iPads, right? They're not shiny. They don't just do what you want on command, and somebody has spent a lot of time making it slick and making it do what it wants. Most of my daughters growing up, this is their first interaction with computers, is iPads and iPhones and things like that, which is cool. I mean, there's nothing wrong with these. They allow access to a lot of things. You can do a lot more things that we couldn't do back in the day on one of these, but they're not rough around the edges, okay? And speaking of Apple, and Steve Jobs has a very famous quote that everybody should learn to programming because it teaches you how to think. Okay, I don't care if you're going to be a programmer, but you should learn to program because if you learn to program, you have to stop, think about what the problem actually is, and what are the steps necessary to solve that problem. Okay, Once you kind of get that down, you can apply that to anything. You can apply that to cinematography. You can apply that to art. You can apply that to marketing. You know, the steps that you have to go through to make a computer do something reoccur time and time again, whether you're talking to somebody else and you're trying to teach them how to put on a stage production, right? So the skill set's very valuable. And the idea behind the Raspberry Pi, and the reason that the Raspberry Pi Foundation exists, which is a nonprofit out of Cambridge University, is to give a not-so-polished little computer experience at $35 you can just give to a kid, you can give them a couple of them sometimes, and that they can go off and mess with and hack with and just play and do whatever and get that experience that we had back when computers were all like this, and gain some understanding of how things work at the lower level. Okay, enough soapboxing. Things you're going to need for your Raspberry Pi. Of course, you're going to need a Raspberry Pi. After you get your Raspberry Pi on the way in, before you start getting hardware, there's a wiki you should probably reference before you start ordering new hardware. Now, if you have some hardware laying around, you can try it out and see if it works and try to get it to work. Before you go buy something, this wiki is great about telling you whether somebody else has tried it, whether it worked, how they got it to work, okay? Because there are some things that work, just plug them right in, and they work with the default drivers, no configuration. So if you're going to go buy something, you want to buy something like that. At minimum, you're going to need a 5-volt power supply that provides 700 milliamps, okay? So it's a little hard to find on the bottom, but if you look about midway in the middle of all that text, there's a line that says 5V, there's some lines, and a 1A, which basically means this is a 5-volt, 1-amp adapter. It's what I use. It's a iPod adapter. iPhone and iPod adapters are really, really good. They almost are always a 1-amp device, okay? So that meets the 700 milliamp minimum spec, right? Because I'm at 1,000 milliamps, 1 amp. You don't want to vary the 5-volt. Okay, you want 5-volt. You don't want 5.1, you don't want 4.9. You start messing with that, you'll get weird things going on, and you may possibly damage the Pi. But it is okay to have more amps. Okay, those are drawn by the Pi. Why would you want more than 700? Because you're going to plug things into your USB port that also draw power. The keyboard and the mouse draw power. If you're going to plug in a wireless network dongle, that draws a lot of power. Okay? You would want at least 1 amp, if not 1.5, if you're going to run a wireless dongle off the Pi itself, off of its state. So that, of course, gets you to the next step of, and last, you will need a 4 gigabyte minimum size SD card. Check the wiki on this if you start going much bigger than 4 gigabytes, okay? Some brands work, some class speeds work, you know, different sizes. But if you start trying to just grab any 32 or 64 gigabyte card, you may find it's not working. The SD card slot on here is not an amazingly fast performant piece of hardware on here. It's actually quite slow. So you'll need HDMI or an HDMI to DVI adapter for the HDMI port. Worst case scenario, you use the RCA jack for video. It's really designed for you to use the HDMI out, and this is kind of a legacy backup device. But also, they might have some other plans with this. So they might use this RCA jack. I've seen some other discussion about what they can do with that, which is why it exists there as well. So you'll need some kind of monitor out to look at everything. And I strongly recommend when you're setting it up that you have a wired network and a powered USB hub, so that all your devices are drawing power from, I got a little D-Link here that I found online, and I spec'd it out by looking at the amperage that the hub had, and this is a 3-amp hub. So it can take a lot of dongles and things hanging out of it. It was pretty cool in that respect. And not draw power from the Pi, so that I can use the power on the Pi for things like overclocking the Pi. I recommend the wired network because your wireless dongle may or may not work. It may work just fine, but it's not getting enough power. And you can just kind of rule that out while you're getting set up. And then once you're set up, if you want to cut over to wireless, you can go for it. Okay, now that you have all the hardware, you're welcome, NOOBS. This actually stands for New Out-of-Box Software. So when the Pi shipped, there was a little bit of shuffling around on SD cards and raw disk image commands, and it varied based on your operating system to get the initial boot out of your Raspberry Pi. So now this new out-of-box software, what it does is it is a download from the Pi website. You copy it to the SD card, just Windows FAT32 partition on the SD card. They'll walk you through the proper way to format an SD card as well as a utility you can use. Copy that over, and when you boot, you'll get a menu look like this that says, what do you want to install? And your options are RaspBian, which is the de facto standard for the Raspberry Pi. If you're going to mess around in Linux, you're going to mess around in RaspBian, which is a Debian derivative of Linux. There are other flavors out there. Pretty much every distro is moving. But the Pi Foundation and most people have kind of centered around RaspBian. Pydora is there. It is a Fedora split. If you're an old Linux guy, you might be more comfortable with Red Hat. You might like RPM over apt-get. So then you could go with Pydora. If you're not familiar with either one, I would say go with RaspBian if you're just starting out. You can also get Arch Linux ARM. And Arch Linux is designed to be a very streamlined, small footprint Linux distro. So it doesn't have a lot of bells and whistles in it. If you want to run Linux and you want to do GPIO and kind of robotic controls and making a weather reading device or something like that, you may want to look into Arch Linux, depending on what you're doing. You may not need to go that low, but if you do, it's there. If Arch Linux isn't cutting it, you can go to RISC OS, which is an operating system that exists solely for ARM devices. So this is the native operating system for the ARM chip. It is a reduced instruction set operating system. It is not a port of anything. It is its own operating system. So if you go there, you are as low as you're going to get and not write your own operating system for the Raspberry Pi. You may want to play with that too, because one of the great things about NOOBS is once you've installed it, it stays on there in a recovery partition. So every time you reboot the Pi, you can go to the recovery partition and say, I've played with Pydora, now I want to play with Arch Linux. And after I'm done playing with Arch Linux, I'm going to go play with RISC. And now I'm going to go back to RaspBian. So you can just wipe and reload your Pi as many times as you want. And the beauty is, you can buy another cheap SD card. And like that is my play-around operating system. And I have this SD card, which is my robotics operating system. And I have this SD card, which is when it's time to play video games on my EmulationStation. So I'm not messing up each operating system. You know, all I have to do is spend money on another 4 gig card or see if I can scrounge one up. You also have two options, RaspBMC and OpenELEC. Both of these install ports of XBMC. At the time of this presentation, I can find no real difference between the two. It may come down to you're trying to use this remote out of the box with one and it's not working and it works with the other or something like that. But performance-wise and everything else-wise, they both seem to be working just fine. RaspBMC started a little sooner, is a little bit older. But they're both installing the exact same Xbox Media Center. XBMC is what that stood for because it's a project that started on the classic Xbox, modding it and turning it into a media center. It no longer actually runs on the classic Xbox. They've moved the code beyond the point where it'll port back to the classic Xbox, but it has become a very wonderful media center. In fact, there's been some commercial endeavors like the Boxy Box, which have taken XBMC and ported it and used it in a commercial application with that. So that's out of the box what you're doing with it. Once you kind of get up and going, at this point I'm going to assume you're running RaspBian. Here's some basic maintenance commands. Again, slides, speakerdeck.com/vinyl. You don't have to write these down. But if you're new to Linux, you're going to want to know these commands. Sudo runs commands as root. Basically, root is the administrative account on a Linux machine. You will normally log in as the Pi user, and then you can type sudo and the name of the command, and then that command will execute with root privileges. That's preferred than logging in as root and then you forget you're logged in as root, and you do something, and now you're back to NOOBS reinstalling your operating system. So it's just kind of a protection. You can go to root if you want. If you're an old Linux hat, you kind of don't even want to use sudo, you just want to log in as root. That's not a reference to a Phil Collins song. That stands for super user do. Okay, I'm glad you smiled and got that. Ifconfig is interface configuration, and that's your networking interface. And the basic thing that this answers is, what is my IP address? So you get it, it booted, you scrolled off the screen where it told you when it booted what the IP address is, and now you forgot and you're trying to get at it remotely. You just type ifconfig real quick, and it'll say, hey, these are my IP addresses. Handy to know. All right, so once you're kind of up and running, the first one that you will sudo is RaspBMC, and this sets configuration options. Remember I said the Raspberry Pi Foundation was out of Cambridge, UK? The Pi boots, it's in English, but it's set to British English. And so instead of getting $, you get pounds. And other weird keyboard things happen. So the first thing you want to do is set your locale and your keyboard configuration so that it works with your US keyboard. You can also in here set your overclock options, some other, whether you want to boot straight to X Windows, the GUI interface, or you want to boot to command prompt. So it's a really nice utility for basic commands. And then the other one you want to run is RPI-update, which will go to the web, check for firmware updates, and if there is a firmware update, download and install it. And it seems every week there is an update. Okay? There's a slight optimization for audio drivers. This handles some resolutions on some displays. This runs slightly efficient. There's a lot of work going on the Raspberry Pi, so every now and then you can just execute an RPI update and update your firmware to the latest. The apt-get command is how you can update the software. So executing apt-get update goes out to the internet, downloads the latest list of all software and all version numbers. So you execute that first. And then you can do an apt-get upgrade, which will go through everything installed on your Raspberry Pi and upgrade it. There's also a dist upgrade, which will go out for the distribution, assuming it's Raspbian. It will go out and update everything for the distribution, but if the distribution has dropped a package, it will delete that package on yours as well. This sometimes happens when they switch, again, sound drivers. Sound is an area of the Pi that's still kind of rough right now, so it's coming to a lot of changes. And they're like, all right, we're dropping these sound drivers in favor of these sound drivers, and we don't want both installed because they're just going to conflict with each other. And so a dist upgrade will remove one and add the other. It won't go out and upgrade, though, anything that you've manually installed. Start X launches X Windows, so if you choose to go to the command prompt, you just execute Start X, and that will take you to X Windows, which is the Unix windowing system. And finally, if you're on Windows, two links here, one to PuTTY, the other to FileZilla. PuTTY is an open source SSH client. There's no Telnet open by default on the Pi, it's SSH, and there's no FTP open on the Pi by default. It's also SSH, and if you go to FileZilla, is a free file transfer client. It'll do FTP, but it'll also do secure FTP and SSH file transfers, so that you can go and, from your Windows machine, start copying things back and forth. If you're running Mac, you have SSH, because you just open up a terminal and it's there, because it's running on a free BSD style core. Okay, so the most popular thing to be doing with your Raspberry Pi is to run it as a game and emulation system. RetroPie is where you want to go if you're going to do that. So RetroPie is really a script that installs a bunch of other various emulators and interfaces and front ends for emulating game systems on the Pi. And it fires up a nice little script that asks you, what do you want to run on it? Right now, some of the big ones are Amiga, Atari 2600, Game Boy Color, Dance, MAME, which is your arcade cabinet emulator, Sega, no, Nintendo, Super Nintendo, PlayStation 1, which I think it's asking a lot. I'm glad they got it on there, but I haven't tried a PlayStation 1 game. I'm not sure how well that's going to run on there, but you can give it a shot. Neo Geo, another series of arcade cabinet and stuff like that. And there's a bunch of little esoteric systems on there as well. So that's kind of what you can get support out of the box for. You can, again, use that GPIO port up here, do some custom wiring, use your original controllers. A lot of documentation on the web how that works. And then one of the cool projects is to build a mini tabletop arcade cabinet. So you take this and then you embed that, track down a good screen that you could use. If you're interested in that, start Googling around, because there's actually quite a number of people who've done this in a number of ways. And it just might be what's your preference, what do you want to play on it, and what do you have access to. It's also a really good project to get someone involved in a Raspberry Pi, okay? Because it's now more than just playing with this hardware. You have a project around it that the adult or the child get involved in and figure things out. Okay, probably the number 2 thing behind that is running Minecraft. If you don't know what Minecraft is, you don't have kids. So, pi.minecraft.net is where you can download the free Minecraft edition. Now, it is based on the Pocket Edition. So it is based on the mobile Minecraft. It's not based on the full version. And it is very limited at the moment. There's no monsters, there's no day-night cycle. It's just sort of creative mode, if you're familiar with Minecraft, right? Just go in and build with it. It supports LAN play, though, so you can hook up some Pis together. The most important thing is that there's an API that you can interact with the Minecraft world while it's running. Okay, so you can place and remove blocks, poll where are things at. So you could add games into Minecraft that are running on another server and interacting based on what's going on in the game. If you don't have access to Java or Python or don't prefer, as long as you have a language that has access to sockets, the raw networking programming, you can actually use the Minecraft API because it's really just sockets, and there's just a default Java and Python library built in. Ultimately, though, hopefully you get involved in some custom development. And Python is the language of choice with the Raspberry Pi. The legend is that the Raspberry Pi is called that because of Python, but they didn't want to be on the nose with it, so they named it PI, not PY. That's what I heard. Python supports pretty much everything the Pi is going to be able to do, including GPIO access, so you can use Python to program the GPIO pins to do whatever robotics or additional functionality that you're doing and interfacing with other boards. Runs PyGame quite well. One cool thing about Python is it's beautifully cross-platform, so you can actually do some dev on a laptop running Windows or Mac and push stuff over to the Pi when you run. You don't have to actually develop on the Pi itself. If you go in RaspBMC to opt/vc source hello_pi, there's a ton of example apps and a ton of example languages. So not just Python, but C and things like that. If you want to see how to work with the GPIO, you can go start there, and there'll be little example scripts for your custom development. Okay, so that is my slides here, and I'm going to cut over now into demoing territory. We're going to hope this works. Power it up. All right, we're booting. This is the recovery console, and I hit Shift right there, and you can see there's NOOBS, and I can come in here. Not only can you change the operating system if that's what you wanted to do, but you could also go into an Edit Config Text menu. Config Text is a little boot file that sits on the Raspberry Pi that sets some boot time settings, such as video modes and what things you need hardware enabled at boot. It's cool to be able to get at this from the recovery console, because it's easy to put into a video mode your monitor doesn't support, and then you'll need to change that text file. And that this actually boots up in 1080p, I think, all the time in an auto detect mode before it cuts over to whatever in your config text file. You also have a browser that, if you're connected to a network that's supported by RaspBMC out of the box, you could fire that up from the recovery console, Google your problem or whatever's going on that you need to do for debugging the Pi. And I'll just exit. So this card is set to boot into RaspBMC, which is the Xbox Media Center emulator here. I haven't gotten a good remote yet that will work with the Pi. I think I'm going to have to build an IR sensor. I got a couple USB IR sensors, but they're old and not supported by even Windows, so getting them to work has been a challenge. There we go. Oh, it was doing an update there. Well, don't crash on me, and I won't have to pull your power. How about that? Thank you. Okay. So this is RaspBMC. I'm interacting with the mouse and keyboard. The Raspberry Pi does support the HDMI 1.4 spec for allowing a device to control it through the TV. I don't know if this television is... no. If you have a newer television that's supporting any kind of control, if there's anything like weird like HDMI control or anything that says it supports on that, it will pass through from your TV through the HDMI to the Pi. So you may have a television that will work with the default remote with the Raspberry Pi. That's fairly new. I haven't seen it working because I haven't had a TV that's fancy enough or new enough to support that. But, all right, so I'll go real quick here into video. So now this video is a 1080p H.264 video on the SD card, right? And I got this one here just to show you that for as low-powered as this is, it does have the GPU horsepower that's going to be able to push all the pixels for any kind of video center. If you're not familiar, this is Lindsay Sterling. YouTube star, is that a thing? Can you say that? She puts up a lot of videos of her and Violin, has been doing it for 5-6 years now, and the production values have keep gotten better and better. And she just put her album like on iTunes, and I think sold a couple 100,000 copies as well. So anyway, I'm a fan there. So that's it running. There's it running with an overlay. I can go back to the home screen even while that's playing. Now, the reason I like this, here is it's dubstep, violin dubstep. All right. Okay. So, I mean, there's not much. It's the media center, but
MPEG-4?
The H.264. Yes, MP4 video file. H.264 is the codec.
Okay. What's
So,
dubstep?
oh, dubstep is this type of music. The bass and wub 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 and the wobble bass and all that kind of stuff. So the other thing out of the box that you can do with the Raspbian Pi here is it supports out-of-the-box AirPlay. So this is a YouTube video I'm playing from my iPhone right now. Iron Man sent it to the screen. So So anything that you could AirPlay over, you could also do on the Media Center, like an Apple TV capability there. So
just take a moment on this. You called up something on your iPhone.
correct.
And it went. It told somewhere out on the internet to play that through your internet connection on your Raspberry Pi.
Right. We're both on the same. We're both on the same subnet. So mine went to the wireless router here, and the Pi is plugged into the same router. So we're on the same subnet. So we don't have to go out to the internet.
So this was already loaded on your machine and just told it to play it.
No. Oh no. The video, YouTube, yes. The YouTube video, the iPhone went to the internet, got the YouTube video, then sent the screen to the Pi.
Right. Okay, the relative complexity of the application on the iPhone, did you write that yourself, or is it something that an app you downloaded?
No, it's a built-in feature of the iPhone. So I can go into a music app, and on your iPhone you'll get a icon that looks like a little box with an arrow in it. And then it says, hey, what do you want to play back on? I found devices. So it's found my Mac here. It's also found the Raspberry Pi, so I can hit RaspBMC, and then I can hit play, and now it's going to play the music file that I just grabbed, which is local on this iPhone, through the Pi.
Okay, so that app queries the Wi-Fi network locally to find out what's out there. Then it offers them to you to just press a button to play it on.
Correct. That's why I called it Iron Man, because if you remember the scene in the movie where he walks into Congress and he plays the video, right? He grabs his device out and he takes over the TV and flicks the video onto the screen. That's what it's like. You know, I just pull up my iPhone and I flick the video to a screen.
See, I thought that was science fiction until just now. It shows how far back I am.
Well, for me, this was the coolest thing in the house, and I spent like 30 minutes grabbing everybody in the house going, watch this, watch this. And everybody's like, you played a YouTube video on the screen. Yes, but I started it from the iPhone, watch this. So it is pretty freaking cool to me as well. And I think, you know, if you're got friends over or, you know, something like that, you want to bring up a photo roll and, you know, show something off, you know, you're just showing grandma photos, right? And you could bring up photos of your cat and say, you know, there's my cat Mika. She forgets she has her tongue out. She's one of those cats that just forgets. So yeah, so that's really cool, I think, feature that normally you'd be buying an Apple TV. And I believe that because it's RaspBMC and it's an open source project, you can do this with Android as well. So if you have an Android device, you may have to install something or get something, but it can also do a remote play as well, because it's not Apple making it, it's an open source group making it.
I just got a Chromecast, which is related to all this.
Very similar, yeah.
Absolutely amazing. I can't use it for my iPhone.
All right. So that is the Media Center. Are you happy now that I clicked the power off from the menu? Let me go ahead here and, make it a habit of unplugging the power from the opposite end, not from the Pi itself. There are tiny little connectors on here. These are prone to breaking, okay? So just save yourself some wear and tear every time you reset it and do it from the other end. So this one I have Raspbian on. We're all good there and there. Okay. This is what Unix looks like when it boots. Pretty much tells you everything that's going on that you could possibly want. If you type in the command dmesg, D-M-E-S-G, it will spit this back out, basically everything that got on here. So If you're looking for a message that says, hey, did it find my network card? Did it identify this joystick? Did it, something like that? That'll get spit out up there. And if you need that, you can go there. By default, I think the password's Raspberry. Pi is the user and Raspberry is the password. I changed it to password. Why not? All right, so the first thing here is I'll show you the EmulationStation, which is I downloaded RetroPie, ran the script, selected the things I wanted to install, copied some games over to it to get an EmulationStation working. So I've got Doom on here, Nintendo, and some arcade games running. So let me exit out real quick. I think there's one thing I got to do. I've been messing with the audio. And because I've been messing with the audio, this card defaults to the analog audio out instead of the HDMI out. Now, this is the NES emulation, which sometimes does not come up working. Give it a second launch here. You're just not liking it today, are you? It was working a moment ago. I can tell you as someone who has played a lot of Mega Man, that it feels like it's running slow. So this doesn't want to run at all right now. Let me go ahead and exit, restart. We'll skip the Nintendo one here. I think Galago is working. So if you install it, getting various things to run is not always straightforward. And some things may work, some may not. You may have to go through a lot of hoops and hurdles to get it all set up. I actually have not spent a lot of time in the arcade and emulating things. Come on. I forget which one of these I had working for the demo. Apparently none. Oh, you know what I may have done? I made a change. I've been working on having it work through the audio out, and I may be running into problems because now I've got the audio going through digital out on the HDMI. The cool thing about playing this emulated, you can just throw in $20 into the machine. So you're not going to be running, a lot of modern gaming out of it, but if, you're nearing 40 and you've got a lot of fond memories of the older arcade games, you can have a lot of fun finding those and loading those up on it. And it seems to do better with MAME than it does on the Nintendo. Let's see if after that ran, if the Nintendo will fire up for us. We'll give it one more shot. Yeah, there we go. Now again, as somebody who has played this game a lot, even now, like this is a sit down for 30 minutes and beat this game again, I can tell you that this is not running at full speed. This is running a little bit slow. I don't know if I should play with some overclocking, and maybe that will fix the issue, or if there's some settings or compilation I need to do. For me, I'll just run the classic Nintendo because I still have classic Nintendo. I'll run on the hardware machine. But it's not a bad emulation. This controller that I'm using was $5 on Amazon. So it's a USB gamepad made to look like a retro Nintendo controller. You can tell that it's not real because it doesn't say Nintendo on it, and it has a big Made in China sticker on the back. So, but it's really kind of cool for a cheap gamepad controller that works in Windows and on Raspberry Pi without really any modification kind of out of the box. I will tell you the one thing that's weird is that the controller doesn't have button 0 wired up. So the first button is button 1, and that has actually caused some problems where some games have hard-coded the first button 0 to be fire, and it doesn't have a button 0. So I've had to hack source code on some Linux games that were hard-coded. The emulators all seem to have a configuration menu, and I've been able to work around that. So that's EmulationStation. Now I hit Start X here, and we'll load into X Windows. So this is the graphical desktop. The most important thing is this guy right here in the bottom right. That's the CPU usage. Because anything you do can spike that guy, and it may just be thinking about it for a second. You can run Office on here, Office apps, spreadsheet, Word. You can run a browser on here. These things are not fast. Okay, I actually would say don't intend to use this as any kind of like document creation, you know, cheap little. There's better devices that do that better. But the reason I'm in X Windows is because Minecraft Pi Edition runs in X Windows. Also, Minecraft the Pi Edition seems to have some issues with resolution. So if you're not in if you're not either 720 or 1080, it may not draw correctly on the screen. It may be offset or something weird. But it's very, very alpha in the first version. So, but it is Minecraft. The world is a 256 cube. That's as big as it gets. And it's pretty much creative mode, but you can do whatever you do in creative mode Minecraft. If you've not played Minecraft, if this is your first time looking at it, just think of a virtual set of Legos. Is a lot what Minecraft is. And it's very, very, very popular. Extremely popular. So, that's all nice and good. Let's go ahead here. I'm going to put this window off to the side. And I'm going to launch idle. And now you see in the bottom, you see the CPU spike? Okay, I click to launch idle. Give it a second. Idle is the Python IDE. Okay, so I'm loading up the interactive IDE. One of the really cool things about Python, and what makes it a great teaching language, although it's definitely usable beyond teaching, is that you have this interactive interpreter so that you can just do that and it'll spit back out an answer. And you can manipulate with code interactively while you're also working on it. So I'm going to import the system package because I need to add the Minecraft API to my path so that it knows where to import it.
You need to shift it a little bit so we can see it out here. It's
is it
4 characters off.
Okay, so those first couple characters are just my prompt. You're not missing anything. The prompt is 3 brackets. You probably missed the 3 though. Sometimes I can get this thing here. Let's see.
Okay.
Yeah.
If it's just 2 characters, I can figure out what they are. No problem.
I'll keep a note here. Well, let's see. I can just bring those 2 over. Let's go ahead and. All right. home pi, oops. And one nice thing about the interactive idle shell is it has some intelligence even beyond just the language. Like here it's helping me figure out what directory do I want. I think it's MCI, API, Python, MCPI is the path I want to add. Now I should be able to import Minecraft, call it MC, and then I'm going to establish a connection to my running instance. By default, it's going to look at localhost, but it can connect remotely as well. Okay, that went without error. So now I should have a world object here. Just to test it, I will post to, oops. And there, you can see, back to game. You can see that that ran there. Finally, by instance, I can get, I believe it's get player position. Nope. W dot get. Oh, player dot get position. I'm used to enter completing it from another IDE. All right, so there's the world coordinates of the player. And I can do a W dot. This might put me inside of a brick. And it did. So X, Y, and Z coordinates. So Y would be my vertical. And there we go. So I'll put me up 10 and then just let me drop down. No damage in this. Now you can do a set block. And give it the position that you want it at. So if I'm at, I don't know how high up I am. So let's try 2, 10. Well, no, that might be too high. We're not see it. Let's try 5 and 2. And then I'm going to do a block 1. See if we saw. OK, so there's what I just set. Now block 1, that kind of is a useless thing for us here. So what we let me import real quick. There we go. So this gives me a array or a reference to those numbers, so that instead of having to know that the ID for that was 1, I could hit B and pick the block that I want. Change it to a diamond block. You're not limited to 1 block. Okay. You could set blocks. So using that as a starting location. And then go to another 3-dimensional set of coordinates, making a cube. Let's go 6. Let's go up to 10. 6. And I'm not really sure what direction that's going. I haven't figured out what I'm oriented at right now. Gold blocks. Bam. Right? So that's kind of a brief introduction to the API that you have. Of course, you can write this. I'm doing this interactively, but you can put this in a Python program, run a script, I've seen people make games within the Minecraft game so that you have moving platforms and things like that. And I really hope, I don't know if they've announced plans to do this yet, but I'd like to see this added onto just vanilla Minecraft as well, the official release as well, to be able to put it in some kind of mode and control it with that, because that'd be kind of cool. So that's Minecraft. Let's get out of this. Log out. All right, and the last thing I'll show here is, like I was talking about, custom development. So you may or may not be familiar with Conway's Game of Life. Conway's Game of Life is not really a game, it's a simulation, right? And what it's saying is, let's go down about here. Based on the number of cells around a cell, what happens to it, okay? So if there is 2 cells in the surrounding 8 cells, okay, the square around it, the cell's okay, right? If there's 3 or more, it suffocates. There's too many cells around it. If there's less than 1, or if there's 1 and less, it dies from starvation, okay? And that is an iteration. So you do that to the entire grid at once. You go through, you calculate every cell, and then you make this next frame, right? If there was exactly 3 or something, I forget, you multiply. It's a cell, a dead cell, okay, here has 3 cells within its range, then it multiplies, okay? It grows, comes back to life. Those other cells, now you can see, starved. So you can do this frame by frame like I'm doing, but I've also got this, because it makes interesting little patterns. On this implementation, I also added maybe, there we go, some custom logic here for different colors. And based on which color would survive, I've been playing around with this, prototyping ideas and game ideas with it. You know, there's some mechanic that I could use to make a game with it that might be fun to play. So far, the answer to that question is no, and that's probably why there aren't many games based on Conway's Game of Life. But it is kind of a fun thing to play with. And all this was done using PyGame. And you saw when I launched it here, I launched it from the console. I didn't have to log into X Windows to run it. I ran it right from the console. Now, I don't know how much is getting cut off, because I'm in a text console window here. So this might actually, how much are you not seeing? Quite a bit, actually. So I said that you could do this in both Windows and the Raspberry Pi, right, and be working on the same game. So that's actually how I wrote this one. So since that's getting cut off and a bit, and I'm kind of done on the presentation there, let's see if I can successfully switch back. And I've got idle up running here on Windows. And this is the same code that runs on both. I can hit F5 here. Oh, and you went to the wrong window. Let me get you. So you can see the same game. I also had support for the mouse. Do its thing. I don't remember what my command was to run the simulation from the keyboard. We will look that up. Quit. Step. All right, well, whatever that is. I'll figure that out later. Let's run through this real quick. Not for like a deep, don't think you have to take a lot of the way to this. I just want to end on kind of what does it look like? What is it, if I'm going to go this route, I'm going to get into the code and in Python, what am I up against? So the beginning here is a bunch of importing packages from Python that I'm going to use later, okay? Then these are just some variables that I'm setting for myself and also defining some colors that I can use later. My init function here is where I check if it's Windows. If we're running on Windows, then I'm going to run in a window. I'm not going to take over full screen. But if I'm running on anything else, I'm going to take over and run full screen. That's just simply because when I was developing it, I didn't want it running outside of a window, right? That wasn't a limitation of Windows. So when you run the game, the first thing we do is we initialize and get a window. And then I do a very old school way of doing game programming, which is I have the idea of a back buffer. So the screen is one buffer, one image, and then there's another image that I edit. And once I'm done editing that image, I make it the live one. And then the other one becomes my back buffer, and I draw to it. So you never see me drawing on the screen. I'm just shifting out a full frame. Pretty much all games do this. I'm doing it by hand in PyGame, simply because I had some hardware issues when I tried to get OpenGL working with the Raspberry Pi. And I ended up getting hardware surface, hardware accelerated drawing going when I did it by hand. If you just let the software render it, you don't have to do that. It'll do a back buffer for you by default. These couple of lines is all it takes to grab the joystick. Basically, you init the joystick subsystem, and then for all the joysticks that you want to activate, you just init them. That'll make them available for programming and loops and polling. A bunch of variables being set. The key one here is the FPS clock, PyGame time clock. This gives me a clock that tells me how long it's been since the last time I've called update on the clock. And the reason you want to do that is you want to make sure the game runs at 30 or 60 frames per second. You need to know how long after you've done all your calculations is left in that 30th of a second if you're running at 30 frames per second. And that's essentially what this helper class will do. It'll pause and add enough delay in your code so that it stays at a stable 30 frames per second. And the simulation doesn't run at, the fastest the computer could possibly run it. All right. So this here, we figure out how much time has elapsed. And I have a couple timers in there. Now, you can do event-based programming in PyGame, or you can do polling. So event-based, basically, you look for PyGame events, and if the event is quit, then I'm going to set running to false, which is what actually will exit my while loop up here. If the event is a key up event, that means the key was let go. Check out the key is. If it's escape, post the event to quit. If it's a space, toggle the alive flag, which means that the simulation is alive. The game of life is running. That's what wasn't working for me at the moment. Oh, I know why. Because I kept hitting this keyboard that's plugged into the Raspberry Pi and not the keyboard that's plugged into the laptop. So, human error there. If the key is the end key, just iterate the game of life one step, right? So I just want to see what's going to happen on the next step. C is to clear the grid. Then we have some event processing for the mouse. So when the mouse button is released, figure out which button was released and where it was released at, and then color the cells red or blue based upon that. Now what I'm actually doing is I have an array set up of the grid, and I'm just storing in that grid ones and zeros and twos, meaning no game or dead cell, red cell, blue cell. And then I'm rendering that out at draw time. Much easier to do that than try to pull your screen and figure out what the colors on the screen are. And then I'm looking for the joystick buttons 8 and 9, which on this gamepad are start and select, which will also take a step in the evolution of the game or run the simulation. Okay? Down here, I'm doing the other style. Remember I said you could do this event-based thing and wait for events to happen in the operating system, or you could just do some polling and do it every frame of execution. So I actually don't want to do this joy timer every frame of execution. I want to wait for 70 milliseconds to have elapsed. Because if you push down a gamepad and I don't put that delay in there, the cursor will shoot over all the way. Because this will constantly poll it. It's down, it's down, it's down, it's down, it's down, it's down, it's down. And every frame, 30 frames per second, will move the cursor one square over, faster than you'll catch it with your eye. So I put a 70 millisecond delay in there. That felt good for controlling it. I tweaked that up. So every 70 milliseconds, I poll. The reason I don't use the events here is they're not as fine-grained a resolution. The button has to be pressed or released. That has to become an event. Then I have to catch that on my next cycle when I poll the events. That made my controls feel behind and laggy. So I went to the method of polling the joystick. Then basically, if we're live and the update timer has tripped, basically every half second is what I've got it set at now, 500 milliseconds, or we're taking in a step, the update call is what will calculate the next phase of the game of life. We'll set the step to false so we don't activate it again. We'll reset our timers here. The update joystick is what actually pulled the joystick, by the way. Here's where I draw my back buffer. So I call this draw method, and it draws, everything gets drawn to my back buffer, and there's a boolean whether or not joystick's enabled. I'll show you why in a minute. Then this win blit. Win is the window. Blit is a common function for copying an array of bits from one place to another, and it does it really fast, and it doesn't check about anything. It just copy all these from here to here and go do it as fast as you can. So that's what copies my back buffer to my fore buffer, right? So then people see it. On Windows and some operating systems, you may need to call display update. The Pi doesn't need it. Windows seems to need it. And then again, here's my frames per second clock, where I said that it'll sit here and drain out the clock at a rate of 30 frames per second. So I don't even have to figure out what the delta is. It knows, since I called get time at the start, how much time has elapsed until now, and then figures out how long do I have to sit here before I go on. And this will idle. So it will allow the CPU to do other things while it's waiting. There's a method that you can call that will not idle, that will hold the CPU until the next cycle. Depends on the operating system you're on. If you're on Windows, don't hold the CPU. Other things are going on. On the Raspberry Pi, maybe you want to hold the CPU. You'll get a more accurate frames per second count if you hold the CPU, but you don't let other things run in the background. When we exit our loop, we quit. So there's a setup for the window. This basically figures out how big is our window, and therefore divide the grid up into a number of cells based upon how many cells I've got set in my setting. I'm not going to get into a whole lot of default there. The one thing I do create is a surface. So I have my back buffer, and I have the window surface. I create a third surface for that yellow square. And the reason I do that is he needs to be transparent. Because if he's over a red or blue square, he needs to reflect that he's red or blue. In the default drawing function, there's no room for transparency in PyGame. So I had to use a surface and then blit that where it belongs in the screen rather than do that. That's the only reason it gets a little fancy there. Here's the draw call. All the draw call does is loop through the entire grid. It does some calculation based upon where you're at in the array, how big is the screen. That means this grid is these coordinates on the screen. And then draw a colored block, red, blue, or white, that goes there. So every frame, every cell is being drawn. Okay? Obviously, you could optimize that with this back buffer concept of only drawing the chain cells, but that'd be more logic doing there. If the joystick is enabled, then we'll go ahead and draw the yellow highlighted box. That's why that gets passed into the draw call. The update. So this implements that game of life algorithm. It's not that complicated. The tricky part, really, is just to walk around and get the adjacent cells, which, since I have them in an array, is not that hard to figure out. Well, if I'm at 5, 5, Then I want to go back to 4, 5, 4, 4, 4, 6. You know, you can figure out those numbers that you want to get, figure out what those cells are, return the number of cells that were alive, and then based upon the living count, if we're less than 1 or greater than 4, then we're dead. That's what state 0 is. If we equal 3, we're going to be alive no matter what. Okay, we're either going to come back alive or we're going to be alive. And we figure out what color it should be. And then my addition here was, if I couldn't figure out what the color was because it was even, the cell stayed dead. Okay, it was just a neutral thing. I've come in here, you can see I got a comment right now. I've been hacking with this and turning it up, turning it down, playing with the rules of life, and just having fun with it down there. Once we figured out where all the new cells are at, we replace the array of cells so that when we do our draw call on the array of cells, they're updated. Here's what getting the joystick looks like raw when you're pulling it. You just get access or get button. The D-pad, even though these are technically buttons, show as an axis, -1 to 1. Okay, so it'll act just like a thumbstick would. That's pretty standard across all platforms and game programming languages. And then last here, like I said, it's pretty easy once you know your cell to get the surrounding cells in your array. So it's, again, not meant to be like a learning Python session, just kind of like this is what the code is, this is what you're up against. So that's it. That's what I have for Intro to Pi. So hopefully you've got some ideas of what to do.